Okay, now that we know about radian measures, we're going to redo our table for the sine, cosine, and tangent of the quadrantal angles and then the special angles. So these, remember, are our quadrantal angles. And then these we refer to as the special triangle angles. And all of these are degrees. So first let's go through and convert them all to radians. So walking around the unit circle and looking at our special quadrantal angles and thinking in terms of pi. So this would be 0 degrees, it's 0 pi. Up here 90 degrees and 180 degrees and 270 degrees. We know 180 is pi radians. At the top 90, that's pi divided by 2. And 270 is 3 pi divided by 2. So it's 90 times 3 if you want. 90 times 3 is 270. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Let's keep going with the radians. Pi, recall, is, maybe you want to write this at the top, that 180 degrees is equivalent to pi radians. So 30 degrees would come from pi divided by 6. 45 degrees comes from pi divided by 4. And 60 degrees comes from pi divided by 3. I could also, on the side, if you're concerned, we're taking 30 degrees and converting it to radians. So we would do that work. 45 degrees, converting it to radians from yesterday. And then 60 degrees, converting it to radians. We multiply by pi over 180. So then when I reduce each of these, we get our values. Okay? You can try those out on your calculator. So now that we have that part, let's go and fill in the table. So we're filling in for sine, cosine, and tangent of these values. And then we'll do the special angles after that. So the table's the same. Walking around the unit circle, we know our points are 1, 0, 0, 1 at the top, negative 1, 0, and 0, negative 1 at the bottom. And so remembering also that the cosine is our x coordinate and the sine is our y coordinate, and that tangent is sine divided by cosine. So all these little reminders from chapter 9 are still in play. So let's walk around the unit circle and find the y values for 0 degrees or 0 radians. The y value for pi over 2 radians. The y value for pi. The y value for 3 pi over 2. And the y value back at 360. Then the x coordinate in the unit circle for 0 radians, the x coordinate is 1. For pi over 2, or 90 degrees, the x value is 0. Keep going around, negative 1, 0, and back to 1. This same chart is in your chapter 9 notes, but we didn't have radians then, so this is the only new part. Tangent of an angle equals the sine of the angle over the cosine of the angle. So we know we get 0 and undefined, and 0, undefined, and 0. Of course, this chart could also continue for cotangent, secant, and cosecant, but having this is enough Again, we're just practicing the radians. So now our 30, 45, 60, 1, 2, 3, 3, 2, 1. Everybody gets a 2 in their denominator. And the numerators get a square root. Tangent is sine over cosine. Remember, as long as your denominators are the same, you can take the top of the sine over the top of the cosine. So that equals that, which rationalizes. We have radical 2 divided by radical 2 is tan of 45 is 1. Tan of pi over 4 equals 1. And for pi over 3, we have radical 3. So there's a little reminder, a little refresher. Our chart still matters. All right, so now we're going to try some examples. Now remember, you have to be able to read, you have to be able to notice things like find the exact function value. And that's the French word, of course, for use a chart. The French phrase for use a chart. That didn't work very well. There you go. So the tangent of pi over 3. Once we have our chart made, we can just go and look. Tangent of pi over 3, right here, is the square root of 3. If you avoid your radians and you convert this, then you'll see you have 180 degrees over 3. So it's the tangent of 60 degrees, and use your old chart, still radical 3. Sine of 4 pi over 3 takes a little more work. So this one I'm actually going to convert. I don't have a 4 pi over 3 up in my chart. So 4 pi over 3 is the same as 4 times 180 degrees divided by 3, or 240 degrees. Do a little sketch for 240 degrees. I know that my angle ends up in quadrant 3. And when I'm in a different quadrant, I need to use the reference angle. So what we're going back to for a question like this is QRS. We're in quadrant 3. For 240 degrees, we're going to subtract 180 and get our reference angle of 60. And the sign of sine in quadrant 3 is negative. So then rebuilding this question, negative, with the function negative sine of 60. Now I know I'm looking at my chart, and the sine of 60 is the square root of 3 over 2. So I have negative square root of 3 over 2. So think about all the steps that you need to do just to do a simple problem like that. You're putting a lot of information together. All right, oh, here's secant. So we didn't do our table for secant and all of the reciprocal functions. So you might know that the cosine of pi over 3 is 1/2. Look at your table, it's the cosine of 60. And secant is the reciprocal for cosine. So it is the flip of this answer, which is 2. Here's another reciprocal function, cotangent. Let's see, pi over 4 is in our chart. That's 45 degrees. Again, if you're more comfortable with degrees, then you're going to be doing some extra work figuring out that that's 45 degrees. That's okay as long as you're pretty quick. So some of you might recall the tangent of 45 degrees is radical 2 over 2. When that is flipped, it's a lot more work actually to do all of this. You might remember that it comes out to just be radical 2. Cosine of pi over 6. Go ahead and look at the chart. Cosine is in there. Same as the cosine of 30 degrees. Excellent. Sine, here's our 45. Sine of pi over 4 radians. It's radical 2 over 2. Tangent of pi over 2. So that's halfway to 180. Tangent of 90. That's one of our undefined values. Tangent is not defined at 90 degrees. And cosecant of pi, well, there's a reciprocal function. So if you know the sine of pi, the sine of 180 is 0. So the cosecant would be 1 over 0, which is also undefined. Another way to do that, or to show the work, is that the cosecant of pi is 1 over the sine of pi. And then you could say it's 1 over 0. And of course you're getting this same answer. All right. Find to the nearest 10,000th. That's 4 decimal places. The radian measure of theta for a first quadrant angle. So you gotta read carefully. It's always important. We have sine of theta equals 0.5379. To get theta alone, we're going to sine inverse both sides. That helps us with what buttons we're pressing. So sine inverse of sine is leaving us with just theta. And now, of course, you're going to hit second sine on your calculator here. But more importantly is your mode. If I want your answer as a decimal in radians, then we have to go to radian mode on your calculator. So please check your calculator right now and change your mode. Instead of degrees, you want radians. So now when you do sine inverse or second sine, checking my mode as well. Okay, radians. Second sine of 0.5379. You get radians, 0.5679 radians. Put the little r there so you realize your answer is in radians. Okay, let's try the next one. Cos inverse both sides. Go ahead and plug that into your calculator. Hitting second cosine. And you should have theta equals 0.5976 radians. And the last one here, tan theta equals 4.7, tan inverse, both sides. And go ahead and do that on your calculator. and to 4 decimal places. I have that. 1.3612. Rounds up just a pinch. Okay, I have one more for you here in this section. So the extra problem is secant theta equals 4.218. So I'm trying to solve for theta. I know that the secant of the angle equals 4.218, but I don't have second secant on my calculator. So to do a problem with the reciprocal functions, you first want to rewrite it as the reciprocal answer, 1 over 4.218. From there, we can cos inverse both sides. Cos inverse of 1 divided by 4.218. And you should get your theta value. Give it a try. Cos inverse, second cos, 1 divided by 4.218. And I have 1.3314 radians for that. I'm going to just check that again. Second cosine, 1 divided by 4.218. And yes, that's what I have. Okay, quick word problem. Let's see if I can do this. There we go. Quick word problem. A supporting cable runs from the ground to the top of a tree that is in danger of falling. So we have a support cable. The tree is 18 feet tall. Pull that out a little bit. The tree is 18 feet tall, and the cable makes an angle of 2 pi over 9 with the ground. Determine the length of the cable. Here's the cable. To the nearest tenth of a foot. So from the angle, we have the opposite and we have the hypotenuse. So with those two sides, we're going to use which function? If you said the sine of the angle, you are correct. So we have the sine of 2 pi over 9 equals 18 over x. So clearly, it doesn't say here, but this is radians. So let's say, if we do the sine of 2 pi over 9, make sure you're in radian mode. And if I do that right now, I'm going to get a big, ugly decimal. So I'm going to cross multiply and say x times the sine of 2 pi over 9 will equal 18 times 1. And to get x alone, I'm dividing both sides by the sine of this radian angle. So x equals, grab your calculator, 18 divided by, make sure you're still in radian modes, sine of 2 pi divided by 9 inside the parentheses, and your answer tells you the value of x, 28.00302888. Hope you got what I got. And to the nearest tenth, then, we have 28.0. Excellent. Let's see what else we have. Oh, orientation's off just a pinch. Okay, so this is an interesting question. We're going to do it together. It takes a little bit of time. We have a nice diagram. Let's read what we have. The x-axis intersects the unit circle R at 1, 0. So here's a unit circle, and R has the coordinates 1, 0. This is a unit circle. And a circle of radius 3 at point A, 3, 0. Okay, so over here, 3, 0. So we know the radius of this bigger circle is 3. All right. The terminal side of an angle ROP, so this angle opening up in green, you can see the green. The terminal side goes through P on the unit circle and B on the bigger circle. So we know then that OP is 1 because it's the unit circle, and OB is the radius of the bigger circle, so that is 3. Okay. The measure of arc, PR, is 2.5. So they're telling us an arc length. So let's see, if we even go back to that little S equals theta R, our arc length is 2.5 with a radius of 1. That means our theta is also 2.5. So the angle here in red, this angle is 2.5 radians. Okay. Oh, excellent. First question. What is the radian measure of angle ROP? So we've already figured that out. It's 2.5 radians. Part B. What is the radian measure of angle AOB? Well, it's the same angle. It opens up the same, whether it's in the small circle or the big circle, it's still 2.5 radians. Part C, what are the coordinates of point P? Okay, point P is on the unit circle. And we know from experience that if we're on the unit circle, the coordinates of our point are cosine theta, sine theta. And since theta is 2.5 for our angle ROP, then we're going to have the cosine of 2.5 radians and the sine of 2.5 radians. And let's use our calculator to estimate what those are. Let's go to the hundredths place. Make sure you're in radian mode. Cosine of 2.5. And I have, let's go to the hundredths, negative 0.80. That's pretty clean. And the sine of 2.5. Rounding to 0.60. All right, great. So point P, let me just label that, is negative 0.8 and positive 0.6. Nice. Part D, what are the coordinates of point B? Well, point B is way out here on the bigger circle. So let's drop this. Let's make a triangle for our reference angles. We know that the radius is 3. Okay. And we know that the angle is 2.5 radians. So if I wanted to find the adjacent side, or x, I would simply say that, let me do a little work right here. There's a little room. The cosine of 2.5 equals the adjacent side over the hypotenuse. Adjacent over hypotenuse. So what I'm going to end up doing is cross-multiplying and saying my x-coordinate is 3 times the cos of 2.5. And a matter of fact, in this bigger circle, my y-coordinate is 3 times the sine of 2.5. So if your radius is larger, it's really just a dilation of the triangle. And dilations multiply the values. Let's see if I can move these down. Oh, I didn't want all that. All right, I'll just rewrite it. So B, the coordinates of B are going to be r times the cosine of theta and r times the sine of theta, the radius or the hypotenuse. So 3 cos of 2.5 radians and 3 sine of 2.5 radians. Go ahead and get an approximation to the hundredths for those. And we're almost done. 3 times the cosine of 2.5 on your calculator, negative 2.40, rounding to the hundredths, and 3 times the sine of 2.5, 1.80, rounding to the hundredths. So that's pretty cool. In what quadrant do P and B lie? Well, we could do this a couple different ways. One thing we can notice is that in both of our answers, the cosine is negative, and the sine is positive. The only quadrant where that occurs, even if we drew it wrong, the only quadrant where that occurs is quadrant 2. So you can't just look at the picture and say, oh, it's quadrant 2. I could have drawn it wrong. The other way to do this is to say, well, I'm going to convert my 2.5 radians into degrees. So how do we convert 2 degrees? Of course, we put our pi radians on the bottom, so they will cancel, and our 180 degrees on the top. So do 2.5 times 180, then divide by pi on your calculator, and you get approximately 143.24 degrees, which of course is quadrant 2. Yay! See you tomorrow.